Good day, viewers. You are welcome back to Tindanious Maths and Science Tutorials. If you are new here, kindly share, like, subscribe and comment for more interesting videos and updates. Now, if you are new here, kindly visit my previous lecture videos on absolute value function, okay? The geometric definition for absolute value function, okay? Today is just a recap. Now, I want to make the statement that the absolute value function is defined piecewise. In other words, absolute value function is a piecewise function. Okay, so I'm going to do a video into details talking about piecewise function. The calculation involves the equation, okay, how to write the equation or the formulas of piecewise functions and how to graph piecewise functions, okay. All right, so the absolute value of a function, so the absolute value of a function, let's say x, is written as what? The absolute value of x, this way, right? Good. Is defined piecewise. We'll talk about piecewise function into details. I promise you that you are going to appreciate piecewise functions. All right, okay. So let's say for positive, we have x this way. All right, good. So for positive, we have x this way. We will say that the absolute value of x should be equal to x. And for negative x, we have the absolute value of x should be equal to negative x. Viewers, let me explain this, okay, for you to understand what is happening over here. Now, for positive x, we have the absolute value of x is equal to s. What it means is this. It means when I have x this way, and I take the absolute value of x, I should get x. So in other words, positive, then positive. What the absolute, where you see the absolute value function, okay, or the absolute symbol, what it does is that it reverses a negative sign to what? To a positive sign. So if I have, let's say, negative 3, okay, and I want to take the absolute value of negative 3. So I'll do it this way, absolute value of negative 3. What it means is this. It means I have my negative 3 already. And this negative 3 is multiplying what? A negative sign. So in other words, negative times negative gives what? Positive. Then I have what? I have my 3. So the absolute symbol or the absolute sign over here just reverses what? The sign to a positive number. So the absolute value function still remains the same, okay? The function itself, this remains the same. It's just that the sign or the polarity reverses. As simple as that. So if I have positive 3 this way, and I take the absolute value of positive 3, I'll still get what? 3. In other words, when I have positive x, and I take the absolute value of positive x, or that same x, I should have what? Positive x. Similarly, if I have negative x, when you know that the absolute of negative x will be what? Will be positive x, right? Negative x. Do you get that? Negative 3. The absolute value of negative 3 is positive 3. So negative x here, when I take the absolute value of that negative x over here, I should get what? I should get x. So viewers, that is the meaning of this whole statement, okay? In summary, when you have x, you take the absolute value of x, you have what? X. When you have negative x, when you take the absolute value of this negative x, I will still have what? I will still have my x. As simple as that. Now, to throw more light on this, let's say, okay, because absolute value function is defined piecewise, which means we are going to have two functions or more, okay? So we are going to split this absolute value function into sub-functions, okay? And this sub-function is defined or is valid or is true when let f of x be equal to the function y, okay, this way. So we know that for piecewise function is denoted this way, right? So what do I have? I have x over here, right? Mm-hmm. And what do I have here? I have what? The negative x over here. And this is only true or defined when our x over here is greater than or equal to 0. Yeah. And this is also true when our x here is less than 0. Viewers, again, do not memorize this. Okay, you are a mathematician. Okay, so far as you are studying maths at the moment, you are a mathematician. And mathematicians shouldn't do root learning. You don't have to incorporate stuff without appreciating the significance. So what does it mean? What does this imply? Good. Now, if I have my number plane this way, you have 0 here, right? And you have 1, 2. These are what? Positive real numbers, right? And you have negative real numbers here. Now, when I say f is greater than or equal to 0, that means I want to consider what? The values to this side. Okay, to this side, right? So which means all values at this side is what? Is positive. So in other words, positive what? X. Do you get that? So even the direction of the inequality sign tells you that you are moving towards this direction, confirming to the fact that there's indeed what? Positive X value or a positive real number. Now here, look at the inequality symbol. It's pointing to this direction, right? Using the number plane, okay, sorry, the number line. When I point towards here, what am I doing? I'm approaching what? The negative what? Real values. Do you get that? So that explains why we have negative x values or negative real numbers. This is value, this is valid, okay? This is true. This is defined when what? X is less than what? 0. As simple as that. Okay, so let f of x which is equal to y. Okay, so the absolute value of this is just this function. Okay, to throw more light on this, let us consider any value, okay, for x and the absolute value of x, as simple as that. Why are we doing it? We want to do this so that we can see the graphical representation of what? Of absolute value functions. In our previous lecture videos, remember under absolute value function, we said the graph looks something like this, something like this, something like this. So you have your y-axis and you have what? Your x-axis. As simple as that. Is that also good? So remember this. When we come to the absolute value function, what we are trying to do is we are going to do what we call mirroring. Okay, mirroring. We want to mirror something. If you, let's, for example, this is my left arm, right? Good. If I mirror this, I'll have to get the same what? The same structure. Okay, nothing changes, but what changes here is what? It's just the position. So here, this is the position of the left hand side. But when I mirror this, I still have the same arm. But on what? But on the right hand side. So if that is the case, let's see something over here. So let's just consider this. So if I have x over here, and I have the absolute value of x over here, viewers, consider any values at all. So let's say I have, let's start with negative 3, okay? If I have negative 3, the absolute of negative 3 is what? Positive what? 3. Now, if I have x to be equal to negative 2, then the absolute value of negative 2 is what? Positive 2. Negative 1, the absolute value of this is positive 1. The absolute value of 0 is still 0. Now let me consider some positive real values. 1. The absolute value of 1 is 1. The absolute value of 2 is 2. The absolute value of 3 is what? Is 3. So viewers, have you seen that way? So you see the mirroring. 3 is here, 3 is also here, but this is negative and this is what? Positive. You get it that way, as simple as that. Let's see how we can graph this, alright? So if I have my xy plane this way, y axis, and I have my x axis this way. So if I have 0 here, this is 1, 2, let's say this is 3, negative 1, negative 2, negative 3, negative 1, negative 2, negative 3 this way. I have 1, 2, then let's say I have 3 over here. So viewers, let's start from this. So negative 3, right? Good. So we can read this way. So if I have negative 3 here, alright, so let's say you have negative 3 here, okay, and you have positive 3. So if this is your negative 3 here, where is the corresponding coordinate for this? So 3, so negative 3, and I have positive 3 over here, so I have it this way, positive 3 over here, okay. This is not actually drawn this way, so that means I have what? There's a point here, right? Good. Then what do I have? A negative 2. So if I have negative 2 here, okay, then negative 2 then to 2, right? And this is the 2 here, right? So I have what? Another point here. I have negative 1, right? So this is negative 1. Then we have what? The corresponding coordinate, which is what? 1. So I have negative 1 here, then marking onto what? That's 1. So negative 1, then I have 1 over here. Then I have my point over here. What do I have? 0, then 0. So we have 0 over here, then another what? 0 there. So that is what? The origin, okay? Now, let's say we have 1, 1, okay? So I will not even bother to look out for the positive ones. Why am I saying that? I'm saying that because I know this has to do with what? Mirroring. So if I have negative 1 here, then positive 1 should be somewhere here. Do you get it that way? If I have negative 2 here, the absolute value of negative 2 should give me what? Positive 2. So I'll just mirror it over here. So I have it this way. Let's say 2 here. Then negative 3 here. The absolute value of negative 3 should be what? Positive 3. So you mirror it over here. So I have something like this. Okay. So if I take away this over here, if I take away this over here, let's grab this. So I have this over here like this, passing through the points, okay, this way, then through the origin. You get it that way, then it follows up this way, this way, this way. As simple as that. So this tells us that this is the graphical representation of the absolute value function. Remember, I said something like this, right? From the origin, you have it this way, then this way. As simple as that. Viewers, this is the end of the tutorials under absolute value functions. Thank you. See you next time.